let's discuss Python optimization. So at the Google, we can search Python optimize.minimize. Then we have scipy reference guide. Okay. Let's magnify. So this is basically uh, the way to undertake minimization. So let's try it. So let's try Google Colab, collab.research.google.com, hashtag create new. Okay, so here it is the scipy. So from scipy.optimize, import, minimize. Let's wait. And then let's create a simple function. Define, very simple function. Define my function, and then x. And then let's return 3 multiplied by x minus 2 square plus 11. Okay, very simple function. And if we minimize this one, the minimized, so we can minimize the function and we know the answer. The minimized value will be 11 and minimum occurs at x equal 2. So let's try it. So let's do, let's go here and then let me copy this one. Copy text and then go up. Okay, send up, and then, okay, this one. And then we can do minimize my function. And then our initial guess would be, let's say, of course, we know the answer, minimize it at 2, but let's assume initial guess is 0.5. And then run it. Well, you find it. So 11 minimum occurs. So let me save this one, temp, and then print temp. Okay, so it found the answer. So function minimize the value to 11, right? This is again the same to this one. So the answer seems correct. So minimum occurs at 11. And then x, optimum value x is 1.99998. So basically, it is the close to 2. And we know this one occurs at 2. So let's point over here. Well, the answer doesn't change. And then if we want to optimize the value, simply we can temp.x. Yes, so minimum occurs this one. So let's put 0 over here, and then we can see the minimized value, and then let's type minimum occurs at here, right? And then print minimized functional value is, and then temp dot, this is a functional fun, so dot fun. Okay, so it is right. Okay. And let's do it. So there is an argument and there is a method. Okay, let's check the method. Okay, so method. My favorite one is lpfgs.p. So if you click this one, you will have explanation about bfgs method. So actually, let's save this one and let's create another one over here. And then here, method is L dot pfgs dot b, and then we do it. Well, I think you don't need this anymore, so let me delete this part and then print it. Then again we got the same answer, right? lpfgsb. Okay, next, what if we have two arguments? Then suppose we want to minimize this one. Suppose we want to minimize fx, which is a factor. Okay. What if we want to minimize x factor? So multiple. So for example, we want to find like a multiplied by x1. So basically x0 minus 2 square plus b multiplied by x1 minus 3 square plus like 4. Okay, so for example, this one, instead of this one, let me use this one over here. And then we don't need this one because it is obvious. So what if we want to minimize this one? And then it is basically it is a ball shape in 3-dimensional space. It is basically a ball. So it reminds of a circle. So we know this function, if we minimize this function, minimum, of course, when x0 equal 2, x1 is 3, and minimize value would be 4. Of course, a and b should be positive. So let me try it. So x naught 2, right? And then here, like here, it is 2. Let's say it is 2 multiplied by x1 minus 3. And then plus 4. Okay, this one. Of course, now, well, okay, there should be plus over here. And of course, we have error because we have now factor, input is factor. We have 2 arguments, but we have only 1 initial guess. So let's say guess. Let's define guess as 0.5 and then 10. Okay, very wild guess. And then let's put guess over here. And then to answer the minimized value, is this one. Wow, I think there is something strange about, yes, because this is linear, so square, okay? And then let's do it again. Okay, so it is exactly we expected. Minimized value is 4, and the minimum occurs at 2 and 3, right? Because it's 2 and 3, okay? What if we want to change this with A, B, and C over here? Okay. So what if we want to change A, B, and C so that maybe A, B, C varies? Maybe we want to find minimized value and A, B, C varies. So this is parameter. So here, this argument part, extra argument passed to the objective function is this derivative. Okay, so for example, my function x and c. So suppose this is c0, and then this one c1, and then c2, and then c3. Now here, not only x, but those parameters are those c0, c1, vector c, basically. This is also input, but what I want to do is I want to fix this c, and I want to find minimized value x given this one, okay? So how to do that? Okay. Oh, by the way, this shouldn't be here. Well, sorry. This one should be here. Okay. Okay. X1, invalid one. So, okay. And then, of course, we don't have a C. So here, let's find this one, argument. So argument is here. Let's say argument is, let's say, parameter. Let's say it is the parameters P, and let's say P equals, first one is C0 is, let's say, 2, C1, okay, let's say this is 3, and then C1 is 2, and then C2 equals 3, and then because C1 is 2, C2 is 3, so minimum should occur at x0 equal 2 and x0, x1 equal 3, right? And this one is irrelevant, but it determines minimized functional value, and let's say it is 11. Okay, this is P and argument P, and the rest run it. Well, now we have answers. So as you expect, minimized functional value is 11 because we have 11. Fourth argument is 11, which is over here. So minimum occurs at 11. And the minimized value should be because this one and this one. So C1, 2, 3. So minimized value should occur at 2 and 3. So this is very close to 2 and 3. Okay, so this is minimum value. Okay. Of course, when you change this one, like 10, okay? Oh, 10 is too obvious, so 100, okay? Now, as you can see, now the minimum value occurs at 2 and almost 100, because now this one is 100. So this is the end of the brief introduction about the Python optimization. Thank you.